How's it going? We're going to be working on some of the Advent of Code problems from 2020. I was working on them earlier and I left off, I think, around 10, so we're going to be working on 11. Um, and before we even pull in the Advent of Code problem, let's start a fresh closure project because we'll want to sort of transfer over notes from uh, the Advent of Code problem into our editor in order to make it easier to sort of like read along and also gain some context. So on the left here, I've got space Emacs open, and all I've done is create a directory and made it a Git repo. So we're going to go ahead and make it a closure project by adding a deps.in file, which is something that closure tooling that's included in Emacs will look for, and also can be used by closure itself to sort of describe and configure the project, including like JVM options, and a host of other things which we won't get into now, but I'd be happy to talk about if somebody wants to. So the one minimal piece of information we will need in here is to tell Clojure where our files are. And so the canonical way to do that in the Clojure ecosystem is to have a source directory. And then I will say that typically people really encourage having really long namespaces to make sure that your projects are unique. But this is a toy project, and honestly, I'm not going to be like releasing it and having to have compete with a huge, the ecosystem of everything in the world. So there's really no reason to make a really long name. So I'm not going to. So source, I said it's in the source directory, and what are we going to call this? Let's call it after the name of the Advent of Code problem, which I'm pulling up right now. And it looks like it's called seeding system. And that's what I'm going to call it then, for lack of a better idea. System.clj. And with luck, this will... I've done something wrong. Oh, it somehow didn't end up in the source directory. Because it somehow didn't, because I didn't tell it to. It's a bug because I didn't mean it to happen. It says, this is read only on disk. Modify buffer read only to? Why would I want this I don't want this to be read only. It says there's a syntax checker, LSP does not exist. I don't know what that means. Let's ignore it for now. So I mean, I'm using LSP is like a server that's running, that's looking at my code, and it's a relatively new thing that I installed, so I'm not surprised that it's giving me little warnings and errors, possibly because I set up something wrong, possibly because of 100 other things that I hope we don't have to worry about here. But if it gets too annoying, maybe I'll try to turn it off. And it's not complaining anymore, which is fine. Probably because the directory didn't exist when I loaded it. That might have been the issue. These things probably expect a certain order, like the directory you're working in to exist before you like start using it. So anyway, for now, it looks good. And then what I did really quickly, because it's just second nature for me, is I ran citerjack-in, which is a shortcut on Emacs to start up another server. So we've got at least 2 servers, probably more, running and looking at my code and giving feedback. And that server is where you're basically taking your text and like it's being put in a data structure and then being sent to the nREPL server, which is running on my computer, and then it'll give you back feedback. And we can look at the REPL probably somewhere in my buffer list. Is this it? Yeah. So here's a REPL that I can type into if I want, but I rarely do that. Instead, I rely on just using the file and evaluating code in the file. Okay, so we don't need to look at this steps file anymore, hopefully. Or we probably will, because we'll probably want another directory to store our inputs in, just to keep those two separated. All right, so the challenge now itself is over here on my right in blue. And what I'm going to do is I'm just going to copy parts of this in and read it in my editor and toggle word wrap so it's easier to read. And I'm just going to I'm going to turn these into comments first because this text is not valid closure code. And then I'm going to start deleting things that I read that I don't think are really relevant to the story, though that's, sometimes that's dangerous because you end up wanting to know the domain words. Like, you reuse the domain words more than you thought you'd have to. It just depends on the problem. So day 11 seating system, I do not remember what we're doing here in Evan code, so I can't help you there. Your plane lands with plenty of time to... I don't remember the story. I think there's a storyline, but your plane lands with plenty of time to spare. The final leg of your journey is a ferry that goes directly to the tropical islands where you can finally start your vacation. Nice. As you reach the waiting area to board the ferry, you realize you're so early, no one else has arrived yet. Okay, so I don't know why that would be useful. By modeling the process people use to choose or abandon their seating in the waiting area. That's an odd phrase. Their seat in the waiting area, you're pretty sure you can predict the best place to sit. Okay. You make a quick map of the seat layout, your puzzle input. Okay. The seat layout looks like a grid. Each position is either floor, an empty seat, L, or an occupied seat. Hash, your example input might look like this, which we haven't copied in. But what I am going to do really quick here is I'm just going to encode this. Maybe this is doing this too early, but it's I'm going to keep this comment and put it next to this code, and we're going to call this I guess there's symbols, right? And we're going to be using this to parse those symbols into meaning, and that'll be useful in thinking about the problem, right? Because a period is maybe less useful to think about than its translation, which is floor. So I'm going to do that really quick, even if we end up throwing this away. L is empty seat. Sorry. And hash, which I have to look for on my keyboard for some reason, is occupied seat. Just trying to not make any typos. Oh, I wrote def and then I didn't, because I can't think of a good name for this. Symbol. What's a good name? Word. Yeah, I'll take it. I like doing this with my hash maps. You kind of have to, it's almost a schema, right? It tells you what's on the left and then what's on the right. It goes really well if you put in so now if you give that, if you're using the hash map like a function and you give it something called symbol, it's very obvious when you're reading it that you're going to get out a word. So it's a decent name, in my opinion. Okay, so now we're going to look at these inputs they gave you. Oh, there's a book called Elements of Closure that talks all about naming, and it's worth reading. Here's our input, and I suppose what I can do here, we can either try to put it right here and put quotes around and put in a data structure, or we can just move to a file right away. This is kind of complicated. I don't know if I want to take the time to turn it into a data structure in the code itself rather than just put it in a file and parse it. So parsing, everyone's favorite part of coding. Resources, so we're going to make a new directory in Clojure projects. Typically, you put your non-code related stuff in a directory called resources, and again, that's canonical, and so I'm just going to do it here for now. And then we're going to call this seating chart example, and I guess I'll make it a .txt. Yeah, because it really doesn't have a format. It's not like a CSV. So it's just like open-ended. Which txt certainly is not very specified what you put in there. Words, you put letters in a txt file, I guess. And I want to create that directory. And now we do have to go back to that deps file, and I might have to run cider quit and jack in again because I don't know if it'll pick up. We'll find out. I don't know, like, if I add, because I need to add resources now to the path, and the question is, will cider automatically pick up that I added that, or will I have to restart it? I know there's lots of attempts to do like more hot code reloading stuff, but until it just kind of works, I'm not gonna go try to force things because you lose a lot of time trying to fix your editor. Or trying to like push the limits on your editor. You know, you're in a niche language, like if you go try to like load more stuff in, it gets hairy real quick. Scene chart example.txt, and I want to turn that into an IO resource. Okay, so it just like, I typed in IO resource, and because I did the namespace / it automatically loaded it, which is nice when it works. When it doesn't work, it's going to be confusing. And I'm just going to load this file in, and hopefully it'll be there. It says nil, it can't pick it up. That could be because I misspelled the name, or because it's not loading. I'll run, there's a thing called cider refresh namespace. I'm gonna try that really quick just to, it gave me an error. Okay, I will ignore. I'm just gonna close my cider REPL, and I'm gonna turn off my cider server and turn it back on. Which you don't have to do too often, and I'm sure there's a way I could. Error in processing filter scan. There's an error at the bottom that I'm gonna hopefully can ignore. Okay, good. Yeah, Emacs giving errors that I ignore, that's, you know, that's my shtick. Until they start getting in the way. So I've created a comment block here, which is just good practice to be in. Otherwise, you might leave code in your projects lying around that you don't actually want to run in production. Not that we're having that issue here, but just second nature again. So I can slurp the file now. That's great. And I guess we could try to parse it now, but honestly we don't know what we're gonna do with it quite yet. So let's just hold off on that. All right, so I'm gonna copy in the next little block of code, or excuse me, next little block of comments. That should be faster. And let's start reading these now. Now you just need to model the people who will be arriving shortly. Fortunately, people are entirely predictable. Yeah, you see, I even wanted to misread that because it's not true. So, right? Like they're saying, fortunately, it's like a joke. People are entirely predictable, but they're not. And I almost read it wrong because I translated it to what would make sense, which is like a problem when you're reading a problem statement, right? Like you can't read what you want to read. You have to read what's actually written, and then maybe you go ask if it's right. But like at least the first time around, entirely predictable and always follow a simple set of rules. All decisions are based on the number of occupied seats adjacent to a given seat. Word toggle is making it so I can't. Word toggle comes with a cost, apparently. I can't like select as easily. So I'm just going to keep scrolling here and delete that. All decisions are based by the seat. So adjacent is does that mean up or down, or does it mean corners? It means close to or near something. You may consider the people up and down your street neighbors, but next door is a person. Adjacent math, maybe? I'm just taking a second to make sure, like, does adjacent mean two angles are adjacent when they have a common side and common vertex? That's not helpful in this case. Maybe they'll give an example. I'm just trying to understand if like someone's in the corner of me, are they adjacent to me? I would think yes, but oh, it's gonna tell me right away, isn't it? Of a given seat, one of the 8 positions immediately up, down, left, right, diagonal. Okay, so diagonals are included. There's the answer. The following rules apply to every seat simultaneously. If a seat is empty, L, and there are no occupied seats adjacent to it, the seat becomes occupied. Okay, so this is kind of, I mean, that's good because that's what I do too. That's, you know, I won't get into it. How I pick a seat on a plane. I guess you don't. I mean, like how you pick a seat when you have a choice. Like this is kind of silly because people typically don't have. I guess they do in some flight systems. Everybody boards, and they get to pick maybe. So these are like rules that seat becomes occupied. If a seat, and so we're gonna end up encoding these. I don't know if we're gonna do that. Let's maybe try to do that right here. If a seat is occupied, and 4 or more seats adjacent to it are also occupied, the seat becomes empty. Wait, what? If a seat is occupied and 4 or more seats adjacent to it are also occupied, the seat becomes empty. That's like weird because what if, like in what order? Like if there are 2 blocks, if somebody sits down and it creates a case where now 4 seats, like 2 people now have 4 seats adjacent to them that are occupied and they both get up, then one of them wouldn't need to have gotten up. So how is it going to pick? I'm gonna leave that for a moment and then come back to it and rerun it in my head to make sure that's actually a problem. Otherwise the seat state does not change. Floor never changes. Seats don't move. Nobody sits on the floor. After one round, these rules, every seat in the example layout becomes occupied. You know what I'm going to have to doing? I'm realizing with these videos is having to break them up in some way because I have to go do something right now really quick. And I'll be back. So I'm going to pause this video and it's going to be in parts, I suppose. And you're just going to have to hope that I don't cheat and think of other problem in between. So I'm back. And if you're looking at the time, it hasn't been that long. So, right. So picking up where we left off, after one round of these rules, every seat in the example layout becomes occupied. Okay. And then we should copy in more of this. Probably copy in all of it. It's a lot longer than previous problems. I'm going to go ahead and comment this out. After a second round, the seats with 4 or more occupied adjacent seats become empty again. Right. Oh, so this is just giving us a what each block is doing here is giving us like a round by round play of how things are changing over time. The process continues for 3 or more rounds. And these are just different seating arrangements. At this point, something interesting happens. The chaos stabilizes, and further applications of these rules cause no seats to change state. People moving around, you count 37 occupied seats. Simulate your seating area by applying the seating rules repeatedly until no seats change state. How many seats end up occupied? Until no seats change state. So we're going to have a recursive function here that's looking for no change. Um, yeah. Prior to this problem, a lot of these I didn't have to. A lot of these advent code challenges, I didn't really have to think about any sort of like algorithms. And this is definitely reeking of. I mean, probably there were algorithms in the other ones, but maybe I could like, maybe I just brute force them, or I like they were simple enough that I sort of intuited them and I don't think of them as algorithms. It's like, well, is a list an algorithm? Is a hash map an algorithm? Is a B tree an algorithm? It's another data structure, but it's also an algorithm, right? So in this case, I don't know the algorithm. I don't know like the data structure algorithm for putting something in there and it'll simultaneously churn on a set of rules until it no longer changes. Actually, I do. That would be like a rules engine, but I have no idea how you encode that. Um, right? Because I mean, I guess these could be rules like, and then every round it would, every new. Yeah, but what's the new input here? Because it just seems like me. I mean, when I say what's the new input, what I mean is like, um, what triggers a change here? Because people moving, I guess the problem I have with people moving triggering the change is I figure it'll be non-deterministic, because like I was getting at earlier, the one that caught my eye was um, this one. If a seat is occupied and four more seats adjacent to it are occupied, the seat also becomes empty. It becomes empty. So that it becomes empty next round is what it means, right? So if we like had the previous state as the input and we're looking to produce the output as the next state, then four more adjacent, we would say, oh, this one should become empty. But how are people getting loaded in? Did they just all randomly choose their starting position? Is that how it works? No, for the example, we got the initial input. The initial seat layout might look like this, and L is occupied. Oh no. Floor, empty seat is L, or occupied seat hash. Okay, all right, I understand what I don't understand here, which is that, okay, I'm pointing to the website right now with my cursor, but it's the same thing as our input over here. Like this one right here, it says, if a seat is empty and there are no occupied seats adjacent to it, it becomes occupied. But which one becomes occupied first, right? Because it's going to matter. So, or you would think it would matter. Like, are they all starting at the, like, is this the top up here? Like above is the top and I'm walking down, or am I walking up? Or like, can I just appear and choose randomly? I guess you would have to say it's random. That's why I mean, that's the problem with these coding challenges, right? It's because like in the real world, I can go ask somebody. I'd need to go ask somebody, right? Like I couldn't just start and assume. But maybe it's telling me and I'm not reading it. I find that this is sometimes something that like I get into that I feel like other people don't, and it tends to be a matter of luck one way or the other. If because like somebody else might not like sit there and obsess about this, or they might just have arrived at a conclusion and gone with it, and like maybe half the time they end up being right, or like it's But to me, it always like unless they explained it to me, it always just seems like luck. Like, oh, you just happened to get it right. I've got to pause again, I think, because somebody's. All right, so we're back, and okay, so my confusion was just over which one would get loaded first. After one round of these rules, every seat in the example becomes occupied. Oh, okay, so every seat becomes occupied. that's how this is resolved, is that it doesn't matter because every seat gets occupied. And then the second one is if you're going to get up because 4 other adjacent seats are occupied, how do we choose that order too? And I guess it's everyone that, so it like doesn't matter if somebody else is standing up to leave and no longer are year 4 occupied. It's like, well, they were there and that pissed me off, so I'm leaving too. Like, even though now no one else is around me, because like there's no order. We all do it simultaneously. This is where the kind of like these domain, they like, this is like a hilarious example of like coding, right? Like, what do I mean? Like like obviously now there's an algorithm, right? Because this isn't like a cycle. Like they're not actually solving an airplane problem. They're like hinting at an algorithm problem. Because if this was an airplane problem, like, and however this would be done, then obviously like we would care that now all the seats are no longer occupied around you. You wouldn't get up. So okay. Okay, so this is they've given us like an example of how this is going to go round by round, and we'll probably want to capture that. Because is it an example, or is it like what has to happen? So it has to happen. So it's almost like a test input, which is good to have. So we'll want to capture that so we can just, because this is way too big for me to like, the input here is too big for me to like look at visually and be like, oh yeah, I got the right answer. Because if even like one is wrong, it's going to be like, if one is wrong on the small input, I will never catch it on the big input, right? But I might mislead myself into thinking that it's correct on the small input. So let's call this seating chart. What is this, like output, I guess. And then I'm going to copy in all these states into this file. I'm going to try to copy in all these states into this, copy paste. There you go. I like what copies and paste from an editor, from a browser to an editor at any given time. It's always a point of confusion for me. In this case, it's P, but like Control V won't work. And then if I switch to like another editor, it'll be like Control V will work, but not paste. And if I'm in my terminal, then it's a different thing. So my brain is like, paste is a very common operation, and the fact that it's not common between, so this is like, I need to concentrate because now there's no text breaking them up. So we've done 1, 2, 3. This is the 4th one. That's correct. So because I'm starting at the beginning, I put the initial one there too. This is somewhat laborious. The other ones were easier up until this point, which is, I noticed that when I like looked at like people working on these, they all like stopped around like, a lot of people stopped around like 14. So I'm expecting this it to get exponentially harder. Okay, so we're gonna need these for later, and they're saying that at one point everything stabilizes, and so basically things don't change. Oh right, so these last two should be the same, and visually that's what they look like. So, all right, we've got two things we can do here, and I think they're pretty independent of each other. One is like basically parsing this input into a structure, which we can deal with a little bit more easier than a whole bunch of characters. And the other one is thinking about how to solve this problem, and that we can probably break up too, meaning there's probably a way I can brute force. I'm using the word brute force, meaning like off the top of my head, just maybe like a for loop or something, and check the simple one. But then I'm pretty sure the bigger one is going to present a challenge. So here again, a problem with the coding challenge is, right, there's no defined, like you have to set your own goals in terms of like what you'll accept as an answer, meaning, accept as an answer in terms of performance, right? Because in the real world, there should be, I guess, some specification of that. Like, oh, your code works on a couple inputs, but we're actually gonna have to deal with a ton, and that should be specified or at least talked about or known enough by the team that like they can't accept, a simple answer, or a slow is not a good word, like the runtime complexity of the algorithm, like or average of the algorithm should be within some bounds. So that all sounded very complicated, right? So like let's just do the parsing the input first, and then I'll probably need to take my dog for a walk. So we already started doing this, and this is a topic on itself, parsing, because there's easy, and then there's simple. Shout out to Rich. And in my opinion, an easy thing to do is usually like, I'll start doing that really quick. Like you just split on it, and then and we'll probably end up doing the easy thing here because the slightly better thing is maybe cost prohibitive. Split lines, and now they're in. Now each line is on its own thing, which is not, now that I'm thinking about that data structure right away isn't that great. Because we're going to want to know adjacent, which is not line by line, right? So like grouping them that way is pretty arbitrary. And in fact, because the data structure in this case, what do we need to know about it? Yeah, this is going to be, we need to think a little bit rather than just start parsing things, because what we care about here is the functions that are run over this input, and that determines what data structure we're putting them in, and vice versa. So what do you need to know? You need to know adjacent. So basically, I think that the pieces of information that we need here, and maybe this is a good opportunity to load in a whiteboard, right? And move things off my desk so that the whiteboard is accessible. Maybe I could do this in another, but let's not. So it seems to me like the things we need to know here are, like, we have a grid, and here's like my shitty drawing of a grid. And if we're here, then we need to check what we care about at an given position is all the things around us. So that's not like to me, I guess there's two ways this, you could put it in vector vectors, and in which case, like, if this is how we do it, in terms of like identifying location, then you would check everything around it, and that's probably the best way to do this. The other way I've sometimes solved this, just depending on like what information you're encoding and how you're using it, is you can also do like a map, and then in as the value, like as the key, you would do the index, and then as the value you could store more information. And really maybe there's a difference in performance, but sometimes it comes down to like how much of the information is index based and how much is not index based. And in this case, it's all, so vector of vectors is in fact fine. So we can go that route, because we can we're gonna have to be careful, and it's a little bit cumbersome to track, but we can. It's the cumbersome meaning like that's inherent. It's inherent complexity. It's not arbitrary complexity. So vectors of vectors is what we're gonna put it into. And in which case, my previous argument about the simple thing that I think is better is you can use things like interparse to sort of create a grammar for your input, and I really like doing that for anything significantly complicated. This case, it's just close. It's just small enough of a set of data that I don't think we need to do that. Like, there's not like crazy grammar rules going on here with the input that we should like pre-validate before we even start working. Everything is like the input is clean. It's not dirty. dirty meaning like there's weird stuff we should be notified early on about. So anyway, split lines, string split lines is the way to go. And now they're in that. And then what we're going to do is, I guess, map over each one of these. And each one of these is a line. So let's just call it a line. Like it's a... Is there a better name for that? I don't think so. Line. Because it's like, well, it's the seating arrangement, but it's not the... It's like a... Oh, it's a row. A row of seating. And then each... So I'm just going to I'm going to grab one of these right quick here so I can mess with it, because this is what I'm dealing with and I don't want to like think abstractly. I just would like to look directly at it. And I guess what I need to do is split just on empty space, not just split. I need to string split because split is nothing. Is that right? Is that the right input? Is it regex first? Yep, my editor is telling me that the regex comes first and that there's an error because you can't. Maybe I did get the order wrong of. Oh, the string comes first. I checked and still got it wrong because I looked at it. So string split takes a. Right, it takes a string and then your regex that you want to split on, and we want to split on no space at all. And so that's what we want here. Only you want to do it on a row of seating, and annoyingly I'm not getting autocomplete in side of that, and then that looks correct. I'm going to do map v here because we're not going to have performance issues with the input, and it can get you in trouble sometimes if you think you have a list and you have a vector, just because certain functions work differently. Though if we were like, if there was a lot of like lazy loading, that would be not a good idea, because the vectors have to be realized right away. Will it matter here? I don't know. I mean, these like, you know, do I need to worry about it? Not really. So, oh, and this doesn't need to be, this is going to mess with me aesthetically. That doesn't have to be in quotes, in parentheses. Okay, so, and then similarly, we want to now also, because we split and then we need to split again. There's a couple ways to do this, and what I'm thinking about is that we want to do something on the inner part, and it's like always a little bit of a guessing game mentally to figure out like, should I do like, can I do a for loop here? Because for loops flatten nested inner loops. And so, wait, I can't just put a for loop in a thread last macro, which would, so now I'm reducing over the entire thing. I'm just going to call this row, and then we're going to map over each row. So we've got a nested thing going on here. Maybe a for loop can make it better, but I'm not going to worry about that. And then inside of this, it's going to be a space, like an unoccupied space. It could be a floor, it could be occupied or unoccupied. Those are options. And what we want to do is our symbol to word that we made earlier. So it's coming symbol to word space. Oh, so we want to call this symbol, I guess. Or maybe we wanted to call the other one space. No, symbol is better. Yeah, I know that's a... Okay, that should parse our input. Oh, it's not. I didn't evaluate that code, so it's not, doesn't know what it is. I didn't evaluate the variable symbol to word, so it had no reference defined. And then that's up there, which is fine. And wrong number arguments 2. Oh, because, wait, actually, wrong number was y. Oh, to reduce, right. Grid, and then grid with this whole thing. Okay, so the error, I'll stop for a second. So the error was that it was like a function's being passed one argument but not two, which it needs. And I mean, if you're going to talk about things that are annoying in Clojure, I guess that wouldn't be annoying elsewhere. Is Clojure's, my understanding is it's sufficient, it's like dynamic enough that like it's very hard to tell you where an error is. But like this, did it give me an error here in this reduce? Because it should have. It should, like, you would think. Well, here it gives me one because grid. But why doesn't reduce complain because there's not two? Because reduce should always take two. I'm just thinking that oh, not reduce takes two. It's the function you pass it to takes two. I guess it doesn't. It's not going to be feedback that the function I'm passing reduce needs to take two arguments. And then I'm a big fan of always passing the second argument to reduce, which is the initial state, even though sometimes it will try to infer. I just feel like it helps to see what you're starting with. And also it doesn't, leave it up to chance that you've messed it up. So let's evaluate this out and look at it. And then I'm going to get rid of this because this is too much output. But, I mean, it does seem to be it's a vector of lists, which is not quite right because, again, I want vector vectors. And then we can make this a little bit smaller. And just take one of them to look at it. Empty seat, floor, empty seat. Okay, so empty seat is like a little bit, we could have cut them as symbols. In fact, maybe we didn't need to do the symbol of the word. I just think it'll make the code, because it's like, if you're reading the code and you're like trying to not juggle more things, then if I have to go back and like check the symbol list, I'm gonna have to go check this map to translate from the symbol to the word when I'm thinking about the problem mentally. So I might as well just do that in the code. There might be good reasons to not do that, but that's what I'm doing for now. So yes. So now we've parsed this. So now that's the easy part. The hard part is thinking about the algorithm, which we'll do a bit here, and then I might need to take a break. So we know it's going to be a loop. We know things are going to occupy up. So I mean, like, getting in the first state would be easy, right? Because there'd just be like, as an example of a smaller input, if we had empty seat, if we've just got, well, the easiest one, I guess it doesn't, like, this maybe doesn't have an empty set. Like this problem input, there's no empty set version because nothing would happen. I guess that would be, we'll handle that first. So if your grid is empty, I'm calling it grid, but it's a seating arrangement. Or seating, let's just call it grid. It's like, the other word is like too open-ended, because you don't, like, grid is better here, I think, because it lets you know that you're looking at a vector of vectors, or it tells me that. And you can do recursion in Clojure with loop and recur, but and it is more performant, and I do it in production, but in these coding challenges, it's often not the holdup, that you don't have the extra benefit that loop and recur does over a function which you're using recursively. And I tend to prefer that other way, because fitting things into, I think it's tail optimized recursion, or not tail optimized recursion. Anyway, the loop in the loop recur always needs to be the top level function, and that can be mentally very challenging to do. It's always possible. It is not easy. For me, at least, I can't do it. So I'm going to actually switch this over to a function, which I'm going to call foo for right now, because I have no idea. And we'll rename this. There, so I'm not, like, foo's not a good name. It's going to take a grid. And I guess, what else would it need to take? Because it kind of only takes its past state. It takes, like, the past state and the previous state, and those could be in one, those could be in one variable, one data structure. Would they need to be, though? Yeah, I guess grid. Yeah, well, we'll just keep them in one. I'm a big fan of, and this, what I want, it's a big argument, but, like, I like passing maps more often to functions, like putting a lot of the information into a map and then just pass that to the function, because I think that allows for better accretion of information to your function. If it's a business function and it's very open-ended what it needs to accept, I think that's the right move. If you're creating, like, more of a math or library function where it's very, like, it's not going to change or not going to need to accept other things, then I think it's cleaner, like, it's easier for humans to use if there is, like, a couple multiple slots to put things in. Like, for example, the map, right, shouldn't be passing a hash map to the map function as, like, the only argument. I think that would be kind of, like, that would be basically ugly. Like, I think it would be hard on humans to kind of, versus what we do with it having two. But for these functions that are like business level functions, that's not the case. Jesus, I'm sorry, I'm rambling here a lot, but I don't normally do this when it's because I'm talking, and so I'm, like, getting into my own head more. I don't typically go into these rants when I'm just writing code. So anyway, we're going to pass it a grid states, I guess, right? Because it's like the states of the grid. And then I'm just writing a function here that would handle, like, the empty set. So what we would do is, to make it easy, previous I guess you would need to know the position you're on if we're going to do this. So we'll do, no, it would always be the last one, except for when it's the first one. So previous state, LL, is LL last? I know last is a function, and FF first is a function. Is there an LL? I'm sorry, so what I'm saying is, there's a second, that you can do on, and get the second thing, and there's a first. And I think there's an FF first. I think this is a historical thing, and this will also be 2. It'll be nothing. Fist. Oh, because I misspelled it. Or is it nothing? Did I just... First. I use a really odd mix of movement keys. Don't know how to create an I sequence from long. Okay, let's drop that because I guess I don't know what ff first does. I was just wondering if there's a way to get the second to last. We will just call last twice. It's a little bit weird. On grid states. And also oh no, it would just be last because we're going to produce the next one. We'll produce it and then we would check it if it's the same. So I guess you could do it either way. You could produce it and then hand it off. You could produce the new state, hand it off to the next iteration of the recursion, and then check to see if it's the same. Or you could check right after you create it and then exit. In this case, if previous, well, because in the case where it's an empty set, last would be nil. Is this even worth thinking about? Am I worried about a problem that doesn't really matter? Because we're never going to have an empty set. It tends to be the case that doing it this way does make it cleaner though, because like even though you might have that state, like the consistency will matter in readability. But what would we do here if it's nil? You wouldn't do anything, you would just exit. I don't think it's worth worrying about. Yeah, I don't think it's worth worrying about the empty set in this case because we're not going to get it. Or at least I don't want to start there because it might be just, I mean, like a lot of this might end up being a red herring in terms of what we have to do, actually have to do. All right, I'm going to pause the video here and do something else. So I'll come back later. We're back. So when we left off, I was thinking about the initial state and now I'm back to thinking about that. And I guess, honestly, it wouldn't need to be a vector of vectors. It would just be a vector if it was empty. So I guess I would say that if it's empty, if the grid states is empty, then we just return the grid states. And I wish it was auto-completing. I don't know why it's not. So it's going to complain because it's giving me a warning because I haven't filled out the second branch of the if statement. But that's fine right now. So basically, this function at least is producing, this will probably help us with our name too. What I'm doing here is I'm producing the next state. So we're like we're creating the grid states. So I guess it would be like initial to grid state. Or maybe, oh, here's what we could do. It could always be like get next grid state, right? So current to next is what I want to currently call this. So like you give it a grid state and we want to get the next one out. So I'm going to change all of these from grid states to grid state. I think that's a good function. And the idea here is now autocomplete. Oh, because I mistyped current. So if we give it this, I just expect to get one out, which is correct. Okay, so, and another thing we could consider here is validation, but that wouldn't be the role of this function, right? The validator function should not be the function that produces the next state. That way we decouple the validation from from the function itself. So this is where like I would pull in spec if like I felt like there was going to be a lot of this going on and we were going to need a lot of feedback. Pull in spec, not for the running system necessarily, though people have done that. They have used spec in production. I've seen that. That's not recommended because it's not performant, but I mean, that's really like up to you. It's up to your company to decide if that's the case. But there might be other libraries out there that, you know, would claim to be better in use than spec for validation. But in this case, I wouldn't like look to spec unless things get really hairy and we're like, I'm like more confused and I need a way to sort of narrow down my error space so I can inspect it, then I could bring in spec, and spec would do a really good job of giving me that feedback. So current state, next state, so far not really doing much. I'm talking more than I normally would because I'm trying to explain myself as I go rather than just write the code. But what if it's not empty? So that's the easy one. And if it isn't empty, then what we need to do is basically produce the next state. So what we would do then is we're going to be reducing over the entire thing, reducing over the entire grid state. Actually, this is probably a good place for a for loop, because we're going to do a nested. So for row in grid, you know what a grid state is now suddenly let's try the rename function. The grid state is too verbose of a term. It's kind of like, of course it's a state. It's a, you know, a grid is a state. It's not helping anyone. So I'm going to change it to grid, and it kind of didn't do the right thing right here for some reason. Maybe that actually it did, and that was already that way. Why does it say in? Did I type in? That's a Python function. They're not actually functions. I can't remember. In Python, there's functions and there's like the things that aren't functions that we don't have to worry about in Lisp. For row grid, and then it would be, this is our kind of like space. I was calling this space. Up there it's called symbol, now it's called space. That's a little bit confusing. I should probably pick on one, because we converted it from a symbol to, you know, what could be a simple, oh, I called it word up here, which isn't good. I'll call this space. And let's try the rename again. Yes, very nice. And then I would have to reevaluate these both. Sometimes I use navigation by S expressions, and sometimes I use Vim key bindings. In case your brain is having trouble understanding like my movement pattern, the answer is it's random. And yes, I would be totally down for all S expression movements, except for not everything enclosure is an S expression, is it? Because there's vectors and stuff. So I like general tools, and navigation by S expression is slightly less general than up, down, left, right, which gets me around quite well. All right, so we're in a for loop, and what we need to do, I guess in one of these examples, is just fill in any empty seat to occupied. So basically, is this going to work? I'm not sure this is actually going to work, because now we're getting a list. I guess we'd have to repart. This is going to get me I think this is going to get, what does it give me right now? If I just do this. Because I think I'm going to flatten the grid by doing it this way. So it needs to be, oh, and then I can just put anything in here for right now, that from current function. Yes, it flattened it, which is fine, because we could just keep track of the size. The alternative would be if I reduced and then reduced on the inner part. I'm just going to keep the for loop for now. This is always like, you want to have high level abstractions, but when you're dealing with grids like this, you always have to break down into, like, later we're going to have to care about the indexes of our vectors, right? Which is like, ideally your vector would be like, you treat it all the same, and you wouldn't, typically you wouldn't care about, like, especially an adjacent, like a column, like vectors aren't meant to describe like column orientation with another vector. So, we've kind of broken the abstraction. I wish why isn't there just like a grid object enclosure? I guess it is a vector of vectors, but just seems like it, you know, there isn't like a one way. There's not a community. There's not a set community way of describing that, and that can cause problems in communication because it's like I don't know if I'm dealing with a grid when you hand me one. You called it a grid, but that doesn't mean it is one. So I mean, like for instance, what I could do here is then. So now what we can do, and these little variables I'm making might end up. This is in a comment block, isn't it? Doesn't need to be because it's a function. It's not a problem that it's there, but we could do these the rules are just conversions because it always happens, right? So in this case, current to how do I, it's like update space to new space. I think this is the direction I'm thinking right now. So I want to do empty seat to occupied seat as a map. And then, and then this needs to be something that's allowed in our set, but now it's occupied. So, I mean, like if I repeat like 10 times, now they're all occupied. So this should be like our phase one, right? Okay, so the issue with this function is we flattened it and we need to unflatten it, which means we'd have to keep track of how many rows there are. God, I hate doing it, but like let's just do count on grid, like n row count grid, and then row count. I was just thinking out loud because it's now it's not going to be a vector anymore because partition. I guess 4 it was already not a vector. So let's get some. We already did rename, so that to do can be removed. And stay in our comment block. I guess this will just update. Let's run our current to new on something. Double check that worked. Empty seat, occupied seat. All right, let's add the other ones. I feel like I'm getting ahead of myself. Am I really solving the problem right now, or am I just kind of thinking out loud and writing in the code? It's a little bit of both because I need to go back here and double check that sort of this direction I'm going to make sense. After the second round, 4 seats. Because what I'm talking about is like, are the rules. All decisions based on occupied seats. One of the occupied positions immediately up to the rules are applied. If the seat is empty and no seats, right? Because I'm not capturing this part, right? So like, I just made what I've encoded here in my space to new space is not correct. It just looked correct for the first example because that's what happened. Really, it needs to follow this. So we need to check the adjacent. So I can't just hand it the space, which is maybe why this for loop isn't going to work. Because the for loop doesn't care about the relative position. It doesn't care about the index. What would care about the index is map indexed would give you the index. I think reduce key value over vector does too, and that's probably what we're going to end up doing. So we're probably going to go back to the reduce over reduce. Is that correct? Do I get the IDX if I reduce over over a vector with reduce? Okay, let's make these different. Okay, so basically, and then this, then my conj. So I'm just like testing out that reduce KV. In fact, the K of the KV in a vector gives me the IDX as the second argument. This is not right, because I need to do that. Yoink, yoink, yoink. I'm just gonna ignore, why is it there? Okay, filled in. I don't care about the V. I'm expecting this to give me a 0. And then, I don't know why it would be different, but just in case, 0, 1. Okay, great. So we're gonna yoink this, oh, and this. We've answered the question of, do we need to, are we gonna use partition? We've answered the question of, do I just delete this? Yeah. I answered the question of, should I do a reduce within a reduce or a for, and the answer is apparently, unless there's a for that gives you the index. Let's consult the index. Let's consult closure, the internet. Closure for loop with, yeah, here's somebody, it's a question. This comprehension, I don't think this isn't like an answer to my question. This is just the docs on for. And I don't think there's anything in here that would tell you. Map index. Oh, they called map index and then did it because map indexed would give you it. Okay, so reduce KV, and and so this is the grid, and the first thing is the I'm gonna say row index. That's like that's very verbose, but if I do like M and N or something, I'm gonna like forget later which one's which, and it's not worth it here. It's not worth like sitting there for 10 minutes being like, oh, I fucked up because I used the M instead of the N, and I meant N for rows, and blah blah blah. So, and then we're gonna immediately reduce again. I know it's painful. Row. I will call this col instead of col. Index is a because I won't mess those up. And we can even do IDX, right? Like that's 2 letters down. Okay, so now we have access to the row. Oh, and it wouldn't really be the column. This would be the new row that we're building up. And this would be the new grid that we're building up. And it wouldn't be the column, it would be the space. But the index would be the column index of that space. And this is where you gotta watch your parentheses. It's not too bad, but you don't want to mess it up. This one, and then the next item. I'm gonna move this down so the formatting is consistent. This is where just like, yeah, I mean, if you have a tip on what you would do differently here, drop it in the comments section. Anyway, so now Okay, now what we're gonna do is conj our new row to our function, which is going to take, and this can still be a map, right? It just needs to, no, it has to take into account, it can't be a map because it's not a one-to-one anymore. I have to take into account the existing grid and its position and if everything is adjacent to it. So this is like, given adjacent, I'm gonna do all this work, and then what's gonna happen is it'll solve the small problem and then not the bigger one, because they'll like, what we'll have to do is go like read about like an algorithm that you would never just intuitively arrive at unless you were like, I don't know, it's like it wouldn't make sense for you to sit there and like think up this algorithm on the spot to solve a problem, but you'll have to do that in this case. And that's where these coding challenges are kind of misleading, is because it's like people don't arrive at math epiphanies mid coding session. There's already like enough to worry about. Like these things were developed at universities with like math, people working on math, not like in the moment on the whiteboard. Like it's like, so you have to like stop and then go, and then your problem becomes not how do we code this problem, but like, can you identify how to talk about the problem so the internet can tell you the answer to this algorithm question? Which is where I fail sometimes because I sit there and beat myself up because I'm like, I should just know how to do super math like in the middle of a coding challenge. Given adjacent spaces, is it all empty? We wrote it down. If a seat L is empty, we can just get rid of this L. And there are no occupied seats adjacent to it, the C becomes empty. So no, we wouldn't write this in the docs. I don't know why I was doing that. And this would have to be a function, no longer just a hash map. So we're gonna take a space. Do we need to take anything else? Yeah, we would need the row IDX and the column IDX. I'm pretty good having those not be, you know what I'm gonna do? I'm gonna do it this way. I'm gonna say that these are in like a, no, just do it this way. We can change it later. I'm just worrying about if it makes, because if they need to be grouped together, it would be nice to have them in like a vector with two elements rather than separated. And so adjacent. So how do we know it's adjacent? It's because it would be like a range over, so like if I'm 0, 0, where's my whiteboard? I mean, this is not something that needs to be explained, but I'm gonna, so if I'm X, Y, and those are both 0, 0. Oh, and then, here's always the problem, because if you go out of bounds, it'll give you an issue, and this is why I sometimes do map instead of vector vectors, because a vector, if you ask for the out of bounds, I think actually nth won't throw an error, but if you just passed it 0, it will. So we'll have to make sure to use the function that's more forgiving than trying to use a vector as a, okay, what am I talking about? I'm saying that a got you for issues is you can do this if you didn't know a vector is a function. It's a data structure, and it should be a comment block. I got burned once because I did some stuff and it wasn't a comment block, so I'm like perpetually wary of doing it again. But I believe if I do this, we'll get an error. Indeed, index out of range. Error is bad because they stop the program. Because the computer's like, I don't know what to do. You gotta tell me. I can't help you. And I know, actually, the question, I don't know if this works. I don't think this will work. No, you have to, because it's only keywords that can be treated as functions. I don't know why I thought. A keyword on a map can be treated as a function. Is a function. But I think nth Yes, you see in the docs on the bottom, you can just load up some docs here instead of me typing an example, but I'll still, I still like to do it. And you see, exactly, here's our example. And this is gonna return nothing found. Awesome. Also, I think there's an option to get not just the closure docs are from the website closure docs, obviously. Well, not obviously, I guess, if you don't know that there's a thing. But I thought I think there's a way to now get the docs for the book. There's like somebody's writing a book on all the closure functions, and they've really like taken a lot of time to describe all of them and like how they're like more than you're getting here in the docs. They like kind of go into like the official, like he read the code and he like talks about various ways they might be used, and also like references other functions that are like it. And it's very cohesive because it's not a group of people. It's like one person spending like years to do this on and off. So like when that's finished, and I think he said he's like letting it become part of the like you can reference it in your editor, and that'll be really useful for in like certain circumstances where you're like, wow, I really need to think about this function quite a bit because it's like it's a hotspot or something, and like you're like, oh shit, I really wish I had an expert here to talk about this function. You could go to that book and he probably would like, pontificate about it quite a bit. So anyway, so we need to look at, we're going to use nth, that's what we learned there. And we need to look at 3 things, and it's got to be from where you are to one below you and one above you, right? So wait, one below you, so deck, so if we start at 1, let's say we're at 0, 0, the first one I always like to do, because that usually hits like corner cases better. So if we're at 0 and we deck 0, and then the one, oh, we wouldn't need to count 3, we just need 2 because it's like on the other side of us. So there's above us, below us, left and right. This is going to be cumbersome. And then it's all going to be for naught. I just know it. Shall I stop right now and just deal with think about that the performance is going to be good enough? No, let's like finish this because I think this will still be useful. Why? What? Oh, because it's up 2. So it's like you have to ink twice. Is there an ink twice? No, that would be awkward. So we're just going to have the +2. And then not... Oh, range isn't very good either. Yeah, I guess range is kind of overkill. So what I want is I guess a set, because the order doesn't matter. A set of like the spaces around me. So I think I'm just gonna end up typing this out, right? All numbers. This is a headache. So anyway, set. So if our space is 0, let's just call that S. Then, does it matter? No spaces are occupied. Does it matter if it's above us? And does like the orientation of the seats ever matter, or can it be a set? If a seat is empty, we just heard that one. If a seat is occupied, I'm gonna get rid of these down here too, because it's like making it harder for me to read now because I look at the word hash. Is the seat occupied and 4 or more seats adjacent to it are also occupied, the seat becomes empty, otherwise the seat does not change. So no, a set is good because the order never matters, and what we just need to encode is everything around us. So I'm just trying to think if there's a clever way to do this, but I'm going to give up because it's not that many spaces. Oh, and our space isn't going to just be 0, 0, right? It's going to be x, y. I don't know why I said 0. So 0, y, or I'm sorry, let's do row idx. I do this sometimes where I do x and y for row and column, and I probably shouldn't have gotten that happen. So inc row idx. So there should be 8 of these, right? idx. Does nth respect a, no, it wouldn't. Does it? Can it do a, no, I don't think so. Okay. I thought maybe it would actually dive in. Okay, but what I am pretty sure about is a social work here, which is why I wanted it to be a tuple. I remembered this in the back of my head, that a soc, because vectors are associative, and you might, this is not a thing you have to do very often, or maybe should do very often. I don't know, one or the other. If it's clever, that's a problem, but I don't think it's clever. I think it's just like, it doesn't come up very often, so it's not common knowledge. Okay, but that's the reason I'm returning a set of vectors, is because now we can take advantage of a soc. Yeah, so if I inc row, that's 1 over, man, this is so boring. You please fast forward until I finish this part. Because I feel like I can't think of a clever way to do this. So on my board here, I'm just gonna mark off what I've done with a blue slash. So that's forward 1. And then I know you've already thought of something clever to do here, and this is killing you. Dec row index. So that handles this one, and then the other 2 are obvious too, because we just every time I have to do one of these grid problems, and it's always just coding challenges, I feel like I have the same headache where I'm just like, is there a function to tell me, what would be, maybe I should make a little util library just for these coding challenges, because they always make me deal with grids, and I'm never entirely convinced of my approach is ideal. It always works. It's just is this the way? The Mandalorian asks you if this is the way. So if we want to do a corner one, it would be inc, we'd inc both. I don't know why, because apparently this new thing I've got, wants to tell me the doc if I highlight it, which is overkill, just to have it tell me the space. And then dec would give us the corner. Code just for this. Inc and dec. So if I ink the row, but deck.
That would be this one.
I just need every variation. Yeah, like I said, this is not clever, and there is almost certainly a mathy. Oh, there's duplicate keys, which isn't good. How many are in here? Because we should have 8. Did I somehow double count? So I'm missing. It should be easy to see because I'm just missing a variant. Ink, deck, ink, deck, ink, ink, deck, deck, and then this one I'll need ink a deck. I wonder if the thing that complained wasn't wrong. It wasn't like reading it, like it hadn't had time to like catch up or something. Yeah, 8, because there should be 8. So this set would be all of the things. So if I eval this without count, yeah, and then pop this. Oh, what the hell? I wanted it to pop it out of the comment block, but it exploded. I'm just going to move this into its own function for right now. It might not deserve that. That might be a bad idea. It might need to, it might make sense for it to be like localized. I mean, for one good reason is right now I'm thinking about a good name, and you know, if you don't have to name it, that's good. Like, it could be things. If you put functions in like namespaces, people are like, oh, is this being used somewhere? Like, should I use this? Should I look at this? And it's like, so if you're like reviewing code and you're like, and there's a function in the namespace and it's really only used once, I mean, that can signal a lot of things. It could mean that like this is a generalized function and you should be thinking about reusing this rather than writing your own. Or it could mean like this was really complicated and I had to pull it out to test it. And it's like maybe after you finish testing it, you should have just moved it back to being local. But maybe you're worried like there might be something more wrong with it. So anyway, there's like, you know, it's not, there's no one formula, but I like to keep things as local as possible. So, because now you know the context it's being used in. Like if it's local, if it's a local function to a function, like then you know it's only used here, and you don't have to worry about broader state or broader uses. Good surrounding. So this is you go from a location, which is a row and column, you give it a location and it's going to return to you a surrounding spaces. Oh, adjacent, that's the word. Oh, so space, actually we can just keep space because that's what we started using. Then maybe loc would be better because, well, space implies like what's in it. So I'm going to say loc because loc, space was what we were using for empty. Like that was our set for there. Like if this was a schema, it would include these guys. But loc is a different thing. Adjacent locs. Yeah, locs is good. Abbreviations are double-edged sword. Oh, and then let's call this once just to make sure. So that's good. And then we'll create another function, which is space to surrounding spaces. And again, these spaces maybe should be, these functions maybe should be localized. Just repeating myself. How would you ever give it a space? You wouldn't ever just give it a space. Because right now we're just saying that's floor empty seat, and that doesn't describe a location. So it would always have to be a location to adjacent spaces, which is fine. Oh, wrong function. So here we're going to do and our loc, which we're going to get, and then maybe we don't even need to do this. I'm getting ahead of myself. Because what we want to do is fulfill these rules. So what we need, the reason we needed this is to see if, to fulfill this rule, if a seat is empty and there are no occupied spaces adjacent to it, the seat becomes occupied. So basically, like we're gonna have a condition and we're gonna update the space if it meets it. I'm gonna go do something else for a second. I'll be back later. All right, so we're back, and now basically we're gonna have this space to do space is going to probably return, maybe it'll return like the location that we're updating and what its new value should be. But let's make a function for each one of these rules. Again, maybe a bit more verbose. I mean, it really depends on the context, because like for this coding challenge, for reading the code, that'll actually make it harder if everything has a name. But it'll make it harder to like understand what the function algorithm is, but it'll make it easier to understand maybe the business rules. So you have like a little bit of a trade-off and I guess one of the ways to get around that is, I mean, that's one of the reasons spec is nice, because it decouples those. Sometimes it decouples those things. But so what we want to do here is basically like we want to like a true or false return statement is and there are no occupied seats. So is empty. Our space is empty. And this is going to take a location. And then what we're going to do is get that we want to get the adjacent locations. Locs from our loc to adjacent locs. Give our loc. And even like making this, putting this in a let variable might be overkill. Sometimes I come down and after I'm finished with everything, just cut all the names out, and it's like 10 lines of code. What was like a 200 lines will come down to like 10. And that's good, because a lot of times when you do that, you realize you've like cluttered the code in a lot of places, because there's like easier transformations that you could have done. But at the start, when you're like trying to understand the problem, I like sort of verbose code, because it matches the business problem, and then you can be sure, and then you could think about how to like decouple them. Adjacent locations, so we have those, and basically what we just need to map through and get the adjacent spaces. So, and do we care, once we have all the locations, do we care about them again? Like, do they need to be connected to the location? I don't think they do. Right, they don't. So we want to get the adjacent spaces. So that function I just deleted, that was empty, we needed. And again, this would have to be loc to well, no, it would just be loc to space. because we've got all the, yeah. That's going to be really easy, isn't it? I don't even need to make a function. Really easy meaning that's a built-in function. Because what I'm going to do is I'm going to map over the adjacent looks. I think the sun is setting, which means my brain is setting too. So I'll probably wrap up after this function. Map over adjacent looks, and what I want to do is just call, no, I can't call grid. I can call nth on the grid, and I can pass it. I never know, like my finger can't touch, I can't mentally reach for the hash key. I have to always look at my keyboard. And then let's just return this right now. Adjacent spaces. And then are we, and then let's give it a location of 0, 0 and a grid of empty. And this is like, you know, will it blow up? It will, because we clash persistent vector cannot be, a persistent vector cannot be cast to a number. A vector can't be cast to a number. Oh, because I'm calling nth here. Association works, but not nth. I think what I wanted was get in. What do I mean? What I mean is, and throw it in the comment section if you feel like this is not the right thing to do, or like there's, because nth is specific for vectors. It's more constrained on intentionally, because like it means that if you're using it, maybe there's performance reasons too, but it also would signal to the reader, like I definitely have a vector that I'm calling on. But get in, I believe, just works on associative structures. So even though it says M and it's typically with M, absolutely you can use it to, just like assoc earlier, will give you back the thing you need. So get in, because our error earlier was like you're trying to treat a vector like a number. Right, and that was happening here when I was using nth, because nth expects the second thing to be right. Oh, I've got nth here on the right in the docs, so it expects this second argument to be a 0. At index, you know, but that's just a word, like it could be, you'd have to go look at the type signature enclosure. You have to go look at the code. So these are all nil. What did I expect? Yeah, nil. That's it. They should all be nil. Like that's kind of the question I asked. I mean, it is like nil is nothing, and that's a vector of nothings, which means it's like it would be nice if Clojure thought a vector of nothings was. I mean, you should never create that, but. It'd be kind of cool if it treated that like a nil. Like if you asked it if a vector of nils was nil, it should say yes, because in my mind that's the case. Like that's the abstraction I would want, but it's definitely not going to do that. It's not going to even do that with an empty vector. But if you call seek on it, or if you call sex on it, nothing happens. But if you call seek on it, it's nil, right? So it's like it's a nil in disguise. And then we want to know if these are all empty. So we want to know if everything in here is empty. What is the way to check if everything is the same thing in data structure? I could put it in a set and check if there's only one and if it's empty. I guess I'll just call, I think there's a function for this. Every always get these confused. Predicate. There's every predicate and there's every, if every predicate is true, this logic is true, if it's true and false. What happened to my screen? Is there something I could do better than that? Because it's set and then I'd have to pull it out and check out it's empty, which is a little bit more, that's like a little bit more awkward. I think this is right. I think I just want to do equal empty over this. And this is going to say nil. Why did it say nil? I expected it to say false. Because it got a vector of nils. And because over here on these examples, every even, it says false. Every, here, let me copy my, there's two ways to do this. We could debug it, or I could pull it into its own little comment block. I mean, you do you on this sort of thing. Like, it's whatever kind of rolls off the tongue easier. I'll explain what everything in a second. This is false. That's clear, right? Okay, so now we're gonna have to do debug because I thought the argument would be adjacent spaces, but it's different than it is. I thought it should just be nils. What's going on here? Oh, I need to call the function. Why didn't it go into the debug
Mode.
Oh, debug mode. Oh, complaints about closure. Again, typically tooling. What is happening? Is this not this function? Like okay, what's happening is I'm setting debug on R space is empty, and then I'm calling it, and it should go, it should drop into this function, but it's not. This is not the kind of thing I would include, because this never happens to me when I'm working. This is like a once in a lifetime thing. Is it because it's in a comment block? Why is it grabbing all of them? Is it because I'm evaluating the, yeah. Okay, I was evaluating the comment block instead of the code. That's why. There we go. Now we're in debug mode. So look at 0, 0. We get all those. Those look great. We're mapping over it. We're getting in the grid, which is nothing nil, which is what I expect. Now we're going to go through all of these. Not very long. False. Oh, okay. So what was happening earlier is it wasn't returning nil. I was evaluating the comment block, and that was returning nil. But it was close enough that I, oh, get out of this. Throws an error for some reason when you exit the debugger. That's not great. And then it printed quit, which is even worse because that makes no sense. Cited made some changes recently, and I feel like he made things worse. Or you know what? Actually, before I blame someone else, it's probably because I installed this LSP thing, and they're like fighting over dominance of my editor. That's what I suspect is happening. I would uninstall and test these things if I was really concerned. Why am I getting all these errors? What is this connected to? Remove yourself from my presence. Comment block. Search failed. Oh no, we've entered into the, like, you've introduced a rogue. If you like, there's all these things in my editor to prevent parentheses not matching, but you totally can still introduce them. Just in various ways, and the editor like goes nuts when it happens. It's trying so hard to like undo that damage or let you know about it. I don't like this. This is like, look at this one reference here in my... Why is it saying one reference in the middle of this? Yeah, this LSP thing is obviously a little bit... The interaction in Emacs is definitely new. So we're beta testing things here. What were you doing? I think what I was doing is saying I was going to pick this up tomorrow. Alternatively, we keep going. Let's see. So our space is empty. That's one rule. And then you can get rid of the screen. It's kind of distracting. And then what I want to do is make the other functions into rules too. Should not take too long. Moving them up here so they can be DP together. A seat is occupied form where seats are adjacent. So defn is really long name. And we may turn these questions into, so we're gonna get like a pattern here real quick, right? All these functions are gonna end up looking the same, and then we're gonna refactor them so they're not the same. Or what I mean is we'll merge the commonalities. So in this case, we're not checking if every is empty. What we want to do is frequencies, because we want to see the count of occupied. And also we need to consider the space itself. So let's not do two things at once. I just realized we have to, up here we have to do that too. This is wrong because this needs to be the same kind of verbose thing. It needs to be the same is empty and there are no occupied seats, right? And more true. This name is more true. So we need, I'm going up here and I'm updating this one first. So the space itself, look, and what we're going to do is we're just going to conj onto this. Conj will work on, oh, it is a list right now. Map returns a list. So space, and then this function no longer exists. I could have used the rename, but I didn't. And that's why I'm like, long names are mostly like a visual issue. Like the typing the characters autocomplete like solves that issue, but and then what are we doing here? So I want to test this with one where my seat is empty really quick. So this is my location. Oh, I would need to create a grid too. Empty. This should be false. Getting the true value here is going to be hard, but writing a test for this would be cumbersome. I trust this code. Like, I mean, I guess like, what would be wrong here is pretty, yeah, what could be wrong here? Every empty, a conj, it's not a list, space, doesn't come back. Well, yeah, I don't think there could be anything wrong. Setting up the test would take a bit longer than is worth it here to check. Space, get in. I can't wait to learn how you can solve this problem in 3 lines of code once we know the trick. And this one is if the seat is empty and 4 spaces. So, I mean, we just need a count of 5, right? It's the same thing. I'm going to adjacent spaces. Gives us back the count, and then I want to know that's equal to 5. Again, we've got a bit of an issue here because creating an example input takes a second. I guess we do need to do it just to feel good. But it. Oh, and also when seats are empty, when it's talking about the 4 being empty, is it including like are your corners where there are no seats? Are you considering those empty? Is nil empty? Is nil empty? What does the input say? Does my question make sense? Meaning like, let's open up our file. It's probably easier to read there. Because I need to articulate this question well. And our directory has some extra files that I would like to be hidden, but I'm not going to bother doing that right now. So, like for instance, this right now on our right, what we have is like the seating arrangement, and the first one's the initial state, and it's asking if 4 around it are empty, and empty is a specific state different than floor. Or is floor considered empty? You would think so. Wait. Does it specify? If a seat is empty and there are no occupied seats around it, the seat becomes occupied. I have to go back and look at the original problem. This is the issue with trimming out information. Because sometimes you learn Yeah, this is the problem when you mix like business terminology with coding instructions, is because like they're like a seat is empty. So presumably what's here is what I'm calling spaces. Maybe I should be calling seats, because like floor is not ever. No, space is better, because if I called it seat, then like floor wouldn't make sense. Because you can't have a seat on the, as awkward as it is to say, like there's set spaces that are always floor. So I would need another word like to describe the general case of floor. I guess, yeah, space is good. So what was I asking here? I'm saying, like, this guy, does he have 4 empty? You see 1? No, you see like L, empty, empty. There'd only be 3. So this wouldn't count. If these, like, over here in the outer rim are nils, so they would have, so nil has to count as empty. True or false? True or false? True. Yes, true. So this is to be empty or nil. How do we do empty or nil? If it's equal, it could be one or the other. With or, that's the answer. How do you do or? The function or. Wait, what am I mean, and this is fine too, because this is like, you know, you are. This is awkward, and you know, this is why I wish, like, I feel like a data structure for grid would be better. I don't know if that would solve it. It's just like, because I have to worry about the indices on the vector, I have to ask if things are like nil, you know. Which is odd. So now we're actually should be getting true on this, because here's our empty grid. Oh, this is a different function. That's where it's nice. The reference thing is nice, because now I know this when I'm. So 0, 0, empty. Expect this to return true. Cool. Okay, because we do want to fill that initial one. And then this one's going to say false. Oh, I guess you know what we can do for our getting a quick test input is we can use the input we have. Which we should just move to a function. What am I doing? Well, can I just macro it up there? Promote function, extract function. Why are there so many? I would be extracting. Analyze, exhaustive search. Input. So I guess like seeding chart file to seeding chart. Is seeding a word I'm using anywhere else? Spaces chart file. Yeah. I called it seeding chart. Yeah, I've used 2 words here, seeding chart and space. Space chart. Yeah, so this would like warrant, if this was production code, it would warrant some like looking at the end to make sure my terminology is consistent. Spaces chart input or file to spaces chart, spaces grid. I can't think of, like, because I've misnamed other things. This one, I'll have to redo all of it. Seems good. Did that do what I wanted? It seems like it. Okay, here it is. That was not worth it. That was not worth your time for me doing that. File. And then where did we leave off on this? We left off with it being done. Okay. Let's clean up this file for a second because I'm having trouble. Okay, and this is to do, not done. So if I come back to the later, I'm not like, what was this? What was I? Like, was this finished? Just hide some of these things. I'm just hiding things so I don't have to look at them because I want to like have enough room on my screen to see the two things I'm worried about. Which is I want to test is occupied and 4 space is empty. So this is our, let's just call it grid. And then is, oh, and then we should take, because this is actually, oh no, this is just one grid. Because we're not looking at this file, we're looking at this one. So is occupied, and then we're passing this our location of 0, 0, and our grid, which again, consistent terminology would be nice. And we expect this to be true. It is in fact. Spaces chart is occupied and 4 occupied. No, we should expect false, which it is in fact false. And then let's run our other function by it, which is empty is empty. This one should be true, and it's false. Oh, because one of them's floor. Wait. Oh, every. What? The instructions make no sense because they said they had to be. So we're counting floor as empty as well. This concept of empty has it is greater than our keyword because empty is like a state of being. It is a function over several things. We might need to upgrade to a case statement. Our symbol to space needs to become a function. What am I trying to say? What I'm saying is that like if floor is also considered empty, which is fine, it's just like it's not clear that that's what they meant when we started, but it is looking at the example, then we can't do a one-to-one mapping. It's not like one thing to another, it's like a function over several things. And I would want to express that somewhere as a one idea. So it's like empty seat, I guess, is fine. That is its own thing, but empty is more than empty seat. And it's not complicated, it's just more. So the space, and it's basically what we've started here, right? If it's the floor, which is fine. I mean the fact that we're using the fact that we're verbose here and talking about floor as opposed to, it's like not clever, which is good because you want people to be able to like look and be like, what is empty? And it's like, well, it's the floor apparently, or it's a nil, and nil is maybe the only awkward business one. It's like, because we access indexes. So it's like, here's a comment because you're reading this and you're like, are you putting nils in your vector? Like, does nil mean something? And it's like, no, it's just because we, access things out of bounds. And so to my earlier point, this is why using using maps can be better sometimes, even though it's a grid. Though in this case, it wouldn't help because you have to count nil. It actually helps to have nil. But nil doesn't leave the area. Why is it giving me a... Why is it saying there's one reference to empty? Oh, because empty is a closure core word and I shouldn't use that. Is space empty? So we had false because floors weren't counted as empty when they need to be, and now they are. Okay, that's... I think I need to make dinner because it's really late. So I'm going to stop here for the moment and we'll come back to this later.